Hi, my name is Woon. I'm a developer at TeckWah, and TeckWah is a packaging and printing and logistics company focused on warehousing. But they're not really Go related. I use Java at work, or rather, the contents for this talk came after I tried writing my blog from scratch. So I had to learn about HTML template in depth. Okay, so this talk is in three parts. So it's like as already introduced, so I guess I won't cover this slide. Okay, so part zero actually, introduction to Go templates. So what are templates? They are most commonly used to generate HTML, i.e. web pages. There may be other users, but I'll focus mainly on HTML. And as sample output may look something like this at the bottom of the slide. Okay, so here's the hello example. There are two files, hello.html and common.html. And hello.html will first call a template called header, then it'll print a line, and then it'll print another template called footer. And in common.html, I'll define a template called header, and I'll define a template called footer. And this is all tied together by using pass files. And then I will pass it into a template variable, and I execute this template variable to standard out using a map string where my name is set to Woon. And the output will look something like this. You will have your header, your I guess the content, and then my name, and then after that the footer. So very straightforward. However, Go's templating system is not like the others. So you may have experience with some other templating engines like Django templates, Jinja 2, Laravel Blade. Their template references are essentially static. So you will include a sub-template by referencing its file path in some template directory. So for example, you may say include partials header.html, and this will reference a file inside a file system. But in Go, these template references are all dynamic, and you must compose the templates yourself. So when you say something like template header, you don't really know which template this header is pointing to because it doesn't reference anything in the file system. It depends on what templates you compose, which brings me to part one, template composition, which is an underdocumented aspect of Go templates. By the way, if you have any questions, just post them in the chat and I'll answer them at the end. Okay, so the big idea is that a template is essentially a map string template data structure. Anytime you do template composition, you're essentially populating this map string template structure. Okay, so on the left-hand side, I have a template file, and on the right-hand side, I'll have the template structure, the map string template structure that it translates to. So if you call pass files like hello.html, you essentially end up with a template that has three templates in it. So you have a hello.html template, and then a footer template, which is from this block here, and a copyright template, which is from this block here. When you execute a line like template footer, you are essentially consulting this map string template structure and pulling out the corresponding template in order to execute it. So once you call footer, it will look up the template and then it will run this template body footer. And then when you're running a template body footer, it will encounter this line template copyright. So it will again consult this map looking for the template called copyright, and then it'll execute a template body. So that's how this lookup system works. So this is another example, the hello world example translated to the same map string template. Now we have two files, hello.html, which, well, it's the same thing, and then the common.html. Okay, so it translates into a map string template structure that looks like that on the right. So now you have four templates within this structure, hello.html, common.html, header, and footer. So essentially a template is a map string template, and one of these templates inside the map is marked as the current template. So I'll go through this block of code on the right, line by line, just to explain what I mean. Okay, so on the left is our sample map string template data structure, and on the right is the code that will, I guess, if you run it, you'll see these results. Okay, so if you call template.name, you'll get the name of the current template. If you execute the template, you will execute the current template. Okay, if you just call execute, but you can execute any template within this structure by calling execute template and passing in the template name. So if you pass in header, you're actually executing this template. Oops. And if you execute footer, you're actually executing this template. And you can iterate through the templates using t.templates, which will just, it's a slice, by the way. So it takes the stuff in this map and converts it into a slice. So the order is actually not defined. You can't rely on any defined order. If you just want the names of the templates inside this structure, you just do t.define templates and it'll return a string with all the names inside. It's, I think, mostly for diagnostic purposes. If you do lookup header, something like t.lookup header, it actually returns the same template structure, but the current template is set to this template they're looking up. So if you do this, it returns a new template where the current template is now set to header. And then since I assign it back to T, then T's current template is now header. So now if you execute it, you're executing the header template. And if you check the name, you actually get header. And if you look up a template that doesn't exist, you get a nil pointer. So you should be checking your template, checking your pointers diligently. So does Go support nested templates? Even though you have a template that looks like a sub-template definition that looks like as though header is a sub-template that belongs to common.html, what actually happens is everything gets translated into this map string template structure. So they all exist as equals. So this code on the right actually is equivalent to the code. I mean, the code on the left is equivalent to the code on the right. So here you're essentially doing hello.html, common.html, you pass nothing because there's nothing other than these two templates. And then you separately pass a header and separately pass a footer. It actually doesn't matter whether you put this header inside common.html or hello.html because they will all be elevated into the same map string template structure anyway. Then do Go templates support template inheritance? Kind of. It's just this same template composition rules that we have been following all along. So why is template inheritance used? Quite often you have a page that pages will be quite similar except for some content in the middle. So for example, you have the same header, same footer, then when you visit this URL, let's say blog post, you want to include this template called index.html. But if you visit a different URL, you still have the same header, you still have the same footer, but you want to include a different template called post.html. The problem is that these includes only point to a specific template in the file system. It's a static reference, so it cannot point to different templates depending on the context. So some people created this concept called template inheritance where you define a parent template. So in here, I'm defining a base template. I'm defining a block called content. And then I'm defining a child template, which extends the parent template and it redefines the block content. And then I'll define another child that extends the same parent template and redefines block content to a different set of output. So looking at base.html, you don't actually know what this block will render because a child may override it. And that brings me to this point where Go templates don't need template inheritance because the references are already dynamically resolved, right? So if you want to change a template to render a different thing, you just overwrite its entry inside this map string template. So in here, it's the same thing. You have a base.html, a template content, and then I'm invoking a template content and I'm immediately defining it. But at the same time, in a separate file, I'm going to define it again. And in another file, I'm going to define it one more time. So looking at base.html, this line right here, you don't actually know what this template content is going to render because if you passed it with base.html, index.html, you're going to render this content. If you pass this and this, you render this content. Or if you pass base.html alone, then you'll render this content. So in fact, Go templates have this block keyword that essentially does the same thing, right? So if you say block content, this is a placeholder, yeah, it's equivalent to defining, equivalent to calling a template called content, and then you're defining it. And then someone else can always overwrite it. It's just syntactic sugar for template followed by define. Okay, so part one, any questions about template composition? Actually, I can't really see a comments right now, so I'll just skip this slide maybe towards the end. Okay, so part two is syntax and variables. Go's template syntax is very minimal. There's only 6 keywords you have to know, and half of them are already covered in part one, define, template, and block. So that only leaves the other 3. There's if, with, and range. Anything else that you can use in a template is a template function. Okay, so before we can talk about those, we must first talk about template variables. So every template has access to exactly one variable denoted by the dot. So this is whatever variable you pass to execute or execute template. Okay, so let's say your dot variable is a struct that looks something like this, right? Params, author, first name, John Doe. The dot will refer to this entire thing, whereas dot params dot author dot last name refers to this specific last name Doe over here. And similarly, if you have your dot as a mat string interface, a nested mat string interface, right? So you've got params, mat string interface, author, last name. It's exactly the same thing. The dot refers to this entire thing. And if you do dot params dot author dot last name, you're doing the same thing where you will look up params, author, last name. So why this works is because Go templates basically uses reflection. So it doesn't really care whether you pass in structs or not. It will just read these strings in, and then after that, dynamically resolve it based on reflection. Alternatively, for maps, you can use this template function called index. So index followed by a map, followed by the map keys. So this line right here is equivalent to this, where you pass in the map, then you want to index, get the params key, followed by the author key, followed by the last name key. Only for maps, not for structs. Okay, so variables must be explicitly passed down to these templates. So for example, if I define a template called footer and I access some kind of variable in it, and if I call this template called footer without passing in anything, it fails because it will try to invoke this thing on a nil variable. You must pass this dot down, then this line will pass. You could also pass a subset of the variables down. So if you define a footer like this, dot first name, then you can pass like params dot author, and then it will pass this subset down, and then this first name variable reference would just work. So variables can be assigned and reassigned. So you have this, you can assign this. You don't want to type this, you can assign to a variable and then use it everywhere, or you could reassign it just like Go. So in Go, you declare variables using this colon equals, then you assign existing variable using equals, same thing. And the scope of a variable exists until the end of the current block. So if it's either if end or with end or range end or just a current template. Okay, so now you have this if, else, end. This is a if statement, which you should already know. So it looks something like if some variable, and then you print this, otherwise you print this. And evaluation is truthy and falsy. Okay, so the falsy values are false, 0, nil, and the empty array slice mat string. So if this variable is any of these, it's considered false, and everything else is considered true. So I used to write code that looked like this, where you would say, if this length of the users equals to 0, then I do this. But you don't have to do that, because if you can just do if users, because an empty slice is already considered false. So this is a lot more readable. Okay, so now I'll talk about the dot and the dollar. The dot refers to the current template variable. So you've already seen the dot will print a variable. You can do a nested access by doing dot params dot user dot first name. But the dollar also refers to the current template variable. So you can do dollar, it's the variable. You can do a nested access by doing dollar dot params dot user dot first name. The difference is that this dot will change depending on the context. And there are only two instances where it would change context, inside with blocks and range blocks. On the other hand, the dollar will always point at the current template variable. It never changes context. And we will see this in this example with the with keyword with variable end. First off, it behaves like an if, okay? So if variable is falsy, this block is not executed at all. But otherwise, the dot is set to the variable inside this with block. So if you want to access anything outside the dot, you must use the dollar. An example, let's say our template variable looks like this, okay? User first name, last name. So with user first name, inside this block, the dot is now the first name. So that's John. If I do first name dot, I print John. But I want to access the last name, and the dot is John. So I need to take the top level dollar sign, which still references the entire thing, $.user.last name. And you can also assign it to a variable, and then you can use it everywhere. So the dot is still the same, except you can now use first name for dot also. It's just more readable, so you don't have this weird cryptic dot everywhere. So the last keyword is range. So it loops over this variable, and the variable must be an array a slice, map, or channel. And if there's 0 elements, then the else block inside here is executed. So again, the dot is changed to each successive element inside the array, slice, map, or channel. If you want to access anything outside the dot, use the dollar. So this is a basic example. You range users. Inside this block, the dot is now set to this John Doe, and then it is set to Jane Doe. And if you want to access today, which is outside this slice, you must use the dollar. Alternatively, you can also assign it to a variable. So now if you assign it to a variable, the dot is equal to the user, the first name is equal to user.firstname. And same thing, today is still accessed the same way. And lastly, you can use index to the two variable syntax, I guess. So if users is a slice, I will be the index, user will be the value, and everything follows. But if this thing here is a map, then this is the key and this is a value instead. So yeah, key, and then the dot is set to the value. For maps, if the order, if I'm not wrong, is if the key is sortable, it will be iterated in the sorted order. Otherwise, if it's not sortable, comparable, yeah, if they can be compared using the double equal sign, then it'll be sorted. Otherwise, it won't be sorted. Okay, so the part 3 is functions, methods, and pipes. So templates already have some default functions that you can already use. So there's AND. So you can do if AND, condition, as many conditions as you want. It will gather them up and then it will run the AND on all of them. Or you could use the OR, which is the other equivalent, the OR equivalent, or the NOT, which is just accepts one condition and then AND. There's length, which will check the length of a variable, where the variable is either a string, a slice, an array, map, or channel. Or you could use index. If you do index a slice, you must pass in numbers and you'll access the slice elements. If you pass in a map, you can pass in the key elements and you'll access the map accordingly. However, templates can call user-defined functions. So this is how you can really extend your templates, I guess. So let's say you define a new template, you define a greet function using this funcs method, and then you can use it inside your code. So like greet Bob, it'll print it'll print hello Bob. These functions can take any number of arguments but must return one result. So you can return a string, an interface, or custom type, whatever. You can optionally return an error additionally. And if this error return is non-nil, it will halt the template execution. Templates can also call methods. So if you have a type user and you have a greet method on this user, if you parse, if you've got something like user.greetBob, then you just pass in the user. You do it like this, it'll basically call the method implicitly, and then you can pass the arguments in. So this will print hello Bob as well, same as just now. However, if you're trying to call a variable, like templates cannot directly call variables that just happen to be functions. If you want to do that, you must use the call function. Okay, so here I'm user has a greet function variable, and I'm passing in a variable, but in order to use it, I must use call.user.greet Bob, and then I will be able to print hello Bob. And the result of one function can be piped into another function. So when you pipe it, the result is passed in as the last argument to the next function. So for example, in here I have two functions. One is called upper, which is just strings.toUpper, and I have the greet, which is takes in the greeting and the name, and then it will return the greeting plus the name. So if I pass it, I do upper dot, that means I'll upper the argument, and then I'll pass it to the last argument to this greet hello. So what actually comes out here is hello Bob, because I pass in Bob over here. It gets uppercase and then it passes into hello Bob like that. Yep. Okay, so this is the end. There's some stuff I didn't cover, which I'm just gonna glide through it like really quick. Templates can be parsed separately and then combined together. Okay, so if you do that, you're basically merging these two map string template data structures. If two templates combine together, then templates may have functions associated with them. How do they interact with each other? Which function will win if two functions have the same name? So The functions are just map string interfaces. They also get merged together using the same logic. So one will override the other. HTML template will automatically secure your HTML, CSS, JS, and your URL input for you. So it will escape them based on the context. So it knows whether it's inside a HTML block, CSS block, JS block, or inside a URL. And even the upcoming break and continue keywords will respect this. So you will not be able to break and continue in a way that will cause the block to change. So maybe I don't really know how to explain it. You'll find out eventually. Yeah. Okay. So functions must be defined before you pass them. So if you pass and then you pass some string that uses a function, it must be defined inside the template before you use it. However, once it's passed, you can overwrite it with any kind of function. So I don't really know why they have the first this restriction to begin with. If you can do this and then just unleash like some weird stuff on it. Yeah. So that's all. That's the last slide. If any questions, I can address them now.
So we have a question from our regular Siwin. So I'll show it on the chat. Why is there a current template?
It's just so that you can execute and then you don't have to explicitly pass in a template name, as I can understand it. So you can just execute it, and since there's a concept of a current template, whatever you execute will be the current template. Yeah.
Okay, so it's probably just like a helpful feature to have a current template, the one that's being used now.
Yeah. I think there was some others. Was there some other template? Current template. Oh, I can. As far as I can tell, that's the only benefit, lah. Yeah.
Okay. So his follow-up question
is
why is there execute and then there's also another one called execute template?
I mean,
over there.
That's I do think that this also means that you can actually, off a single template, you can put your entire website stuff into it, right? All your pages, as long as the names don't override. So you can actually, inside a single template, you want to generate as long as, because maybe they'll use the same dependencies, right? So maybe the header template is always the same, footer template always the same. You can always render a different template depending on the situation, and they will all reference the same templates within this map string template structure. So space efficiency, I don't know, man. They're all pointers, so I don't think I don't think it's very expensive to duplicate it, but yeah.
Yeah, I think it shouldn't be very expensive to duplicate pointers. Probably just for convenience already.
Yeah.
So So one more question. This is pretty long. Have you tried using Go templates to generate actual code? If yes, how do you do unit tests to ensure that the code generator is? I think you can answer the first question first. Have you used Go templates to generate code?
Yes, I have actually. One of my other projects got used templates to generate code. Funny thing, I used to think that the cleanest way to generate code was to use the GoSG package, like to dynamically create an AST and then print it into a file. But that is so complicated. Like that is so, I don't know, man. Yeah, basically the correct way is to use templates. That's a much easier, more streamlined way. Okay, so I have done that. It wasn't code though. It was just struct definitions. I think a lot of packages will do that. A lot of Docker probably does it. Like anything that if you want to overcome any Go shortcomings, you can just use code generation as a tool. So yeah, and to ensure that the code generated is functioning code, actually, if I'm not wrong, you can also use the Go. There's a Go package, one of the AST plugins. You can basically feed in a string and ensure that it's valid Go code. So you can ensure that it's semantically correct. I think you can do, yeah. So I haven't done that though. Actually, I'm not really familiar with that, but basically, yeah, you can do that lah. The thing is, this I only learned about this when someone submitted a pull request for my project that use this feature where basically they pass in the string, the generated code into the back into the Go parser to ensure that the what came out was correct Go output. Yeah. So I'm not familiar with using that, but cool. That's possible.
Okay, so here's a follow-up question. What if the code, okay, so there's a correction to that. So I'll just read out the correction. What if the code that is to be generated is not Golang code? Maybe it's like a JavaScript or Python.
Oh, that sounds super like a
Meta.
yeah, it's like in a realm where I don't know, man. That sounds like you need to pull in an interpreter, or if not, honestly, right, Go is a language where a lot of the answer is just don't do it. You know, you can override package global variables, like io.eof. Okay, just don't do it. So, I think in this case, it's just ensure you don't write bugs, lor. Yeah.